In this step, let's answer question 2. How does the important terminology of Spring Framework relate to what we are doing? Let's get started. Component. A component is nothing but a class which is managed by Spring Framework. How do you tell Spring Framework that something is a component? By adding add component annotation on it. There are other annotations similar to add component, add service, add repository, but the most important one is add component. The next terminology which we typically use, dependency. When it comes to Spring Framework, whenever we talk about a dependency, it is something that you would need to be able to create an instance of a specific class. If I would want to create an instance of the Game Runner class, I would need an instance of the gaming console. You'd either need Mario or Super Contra or Pac-Man. So gaming console implementation, example Mario game, is a dependency of Game Runner class. Next, how does Spring Framework find component classes? We added add component on Mario game and on Game Runner. How does Spring know where to search for component classes? It cannot search all the classes which are present. The way Spring Framework does is it searches specific packages. Now, which packages? That's what is defined by component scan. If you go over to our Learn Spring Framework application class, one of the important annotations which is present on it is at Spring Boot application. And if you look at the documentation for Spring Boot application, one very important part of it is something called at component scan. So what Spring Boot application does is it automatically does a component scan on the current package. So this is what is being done by default. So at component scan, com.in 28 minutes learn Spring Framework. And where did we define all our component classes? If you look at our Game Runner and Mario game, they are in the package com in 28 minutes spring learn spring framework.game. So they are in a sub package of the default package com in 28 minutes spring learn spring framework. And therefore, they are automatically picked up by the Spring Framework. So Spring would do a search in this package, everything in this package which has component on it. If I actually change the view, so right now you'd see that the game is like a separate package, but if you go in here and change package representation to hierarchical, you'd see that game is now a sub package of com in 28 minutes spring learn spring framework. So everything in this package is scanned by default, and that's how our component classes are found. Now, just to illustrate this to you, what I'll do is add a component scan on Learn Spring Framework 1. This is a package that does not exist. So what we are changing is we don't want to scan the default package. We are adding a new package to scan. What do you think will happen? Right click, run as Java application. Oops, error. Why is it throwing an error? It's saying no such bean definition found. What bean is not found? I'm not able to find anything of the type Game Runner. In here, what we are doing is we are creating an application context and trying to get a Game Runner class. However, Spring Framework is not able to find Game Runner class. Why? Because we are scanning a different package. There is no Game Runner class that is defined as part of this package. So when you are using Spring Framework and when you get an error like this, I am unable to find a bean of this type, then typically there are two mistakes that you might be doing. One is your component scan might not be right. You might be putting the component in a package which is outside the default component scan. That's what we are doing in here. I'll remove the component scan. By default, this component scan code which we are writing in here is executed. So when you add an add Spring Boot application, it automatically does a component scan on the current package. So this line of code automatically happens. So what I'm doing is enabling the component scan. And if you run this right now, run as Java application, you would see that it would succeed. So whenever you face problems with Spring, then you might either be misconfiguring your component scan or the class which you need might not have the right annotation. For example, if I go to the Game Runner class and remove the component at component, you'd see the same error come up. So those are the two things that I would typically check whenever I face any problems with Spring applications. So we are now talking about component scan, and we saw that component scan is done on a package. The interesting thing is you can also have multiple packages which can be component scanned. So instead of just one package, you can also configure multiple packages. All that you would need to do if you want to scan multiple packages is at component scan, you can define an array in here. So you can define an array and saying this is com.package1 that I would want to scan, and I can add a similar, and I can copy it and put it as package 2. So this would scan 2 packages. So you can scan as many packages as you would want. Spring is called a DI framework or a dependency injection framework. Why? Because all that it does is dependency injection. What is dependency injection? Identifying the beans, identifying the dependencies of the beans, and wiring them together. Identifying that the beans here are Game Runner, Mario, identifying their dependencies, and creating objects for them. That's what is called dependency injection. And typically, dependency injection is also called inversion of control. Now, what does inversion of control mean? Earlier, we wrote the code to create the objects. So you had to write Java code to create the objects. Now, who's creating the objects? Who's in control? You are no longer in control. The Spring framework is in control. And that's why it's called inversion of control. We are shifting control from our code, from us, to the Spring framework. Spring framework is now managing all the dependencies for us. That's why this is called inversion of control. The next terminology which is typically used is Spring Beans. Over here, Spring identified 2 component classes and created instances of them. So these objects and their lifecycle is managed by the Spring framework. And that's why these are called Spring Beans. What is an IOC container? The technical component inside the Spring framework which manages the lifecycle of beans and dependencies is called IOC container. So when you're launching an application context, what you're launching up is an IOC container. There are 2 types of IOC containers which are used: application context and Bean Factory. I have been working with Spring framework for a long while, more than 15 years, and I've never used Bean Factory at all. For most of the use cases, application context is what is used. So for me, as far as we are talking about IOC container, we are talking about application context. Another terminology you would constantly hear is auto-wiring. The process of identifying the dependencies for a specific bean and making sure that they are wired in together. That's what is called auto-wiring. As you can see in here, there is a lot of complex terminology that is used along with Spring framework. But when you understand the fundamentals, when you have an example, you see that all the terminology becomes very, very easy to understand. I'm sure you're having a wonderful time. I'll see you in the next step.